Good morning. We are doing a test review for lesson 46 through L49 on trigonometry before the unit circle. Before you start, my advice to you would be to go ahead and write down your so-called TOA, which is SOH. Sine goes with opposite over hypotenuse. CA, which is cosine adjacent over your hypotenuse. And your TOA, which is tangent is equal to opposite over your adjacent. That will help you get started in what ratios you need. Ratios are fractions. Your answer needs to be in fractions, no decimal. Number 2 says cosine theta. Cosine is your CA. So cosine theta will be your adjacent over your hypotenuse. If you will look over here, this is your reference angle. So this is the angle point of reference. So this right here will be your adjacent, and this right here will be your hypotenuse. Hypotenuse is always across from 90 degrees. Since you do not have a measurement for your adjacent, this is a right triangle, you will use your Pythagorean theorem. So I'm going to label this one B, or your opposite if that helps you, and I'm going to use my Pythagorean theorem. So you will have 7 squared plus a squared is equal to 21 squared. A and B are interchangeable. Solve for a squared. Minus 7 squared, what you do to one side, you do to the other. That cancels out. On your calculator, you can go 21 squared, let me clear all that, 21 squared minus 7 squared, that'll give you 392. So, a squared is equal to 392. Solve for a. You take a square root of 392, okay? Check to see if that's a perfect square. Square root 392. As you can see, this is a decimal, so you're going to have to break it down manually. So what are some factors of 392? 392 divided by 16 does not give you a whole number, so it does not go into 16. So try 392 divided by 7, which gives you 7 and 56. 7 times 56 equals 392. You can use other factors. Factors of 56 is 7 and 8. Factors of 8 is 4 and 2. Factors of 4 is 2 and 2. As you can see, you have 2 of a kind, and then you have that one left over, okay? So this is the same thing as 2 times 7 with the square root of 2 left over. 2 times 7 comes out to be 14 square roots of 2. So your adjacent side here is 14 square roots of 2. Now that you have your adjacent, you can plug it in into your ratios. Adjacent is 14 square roots of 2 over your hypotenuse, which is 21. See if you can simplify 14 over 21. 7 goes into both. 14 divided by 7 is 2. 21 divided by 7 is 3. That is as low as you're going to get, so your final answer is 2 square roots of 2 over 3. And there you have number 2. Okay. Some a little bit more complicated. Some will be very easy. Number 4. Okay. Tangent. Tangent is your TOA. So, tangent theta is equal to opposite over your adjacent. So there's going to be your ratio. This is your angle of reference, this angle right here. Side of opposite from it, that's your opposite. Side across from 90 is your hypotenuse, as you can see. And this one is your adjacent. Like number 2, you do not have the length for your adjacent. You're going to have to use your Pythagorean theorem. Okay? So, A and B are interchangeable. So you have a squared plus square root of 13 squared is equal to 7 squared. A square root square are inverses of each other. So you have a squared plus 13 is equal to 49, or you can do it all one step. So a squared is equal to 49 minus 13 comes out to be 36. Take a square root. So A is equal to 6. So this right here is 6. Now you can plug into your ratio. Opposite, square root of 13, adjacent, 6. You are finished. Okay? You can't simplify that anymore. Therefore, there's your ratio. Number 6. We are into your secant. So, secant is the reciprocal of your cosine. So, secant theta. Cosine is adjacent over hypotenuse. We will take a reciprocal of that, so it would be hypotenuse over your adjacent. Okay? So this right here is the same thing as 1 over cosine theta, and you take the reciprocal. Angle of reference, 90 degrees. Label your hypotenuse first. This one is your opposite. This one is your adjacent. Now, if you look, you have your measurement for your hypotenuse, and you have your measurement for your adjacent. So therefore, you do not have to use your Pythagorean. We do not need the opposite. So you just go, hypotenuse is 23, adjacent is 6 over square root of 10, okay? You guys see how you have a radical in your denominator? That's one of those rules that you need to fix. You have to rationalize it. So I will continue this over here. So you have 23 over 6 square roots of 10. To rationalize it, you're going to multiply by the value of 1. Square root of 10 over square root of 10 is 10. Multiply across. 23 times square roots of 10 is 23 square roots of 10. Divided by 6. Square root of 10 times the square root of 10 is 10. So that comes out to be 23 square root of 10 over 60. Okay? Now, double check to make sure that that is simplified. 23 divided by 60. See how you get a decimal? Hit math, fraction to double check. Do you see how this is exactly the same? Since they are exactly the same, this is as simple as it's going to get. Always simplify. There's your final answer. Number 8. We are still looking for trig ratios. Okay. On number 8, you have cotangent, theta. Cotangent is your, it's the reciprocal of it is 1 over tangent theta. And tangent theta is opposite over your adjacent. So this is going to be adjacent over your opposite. Okay? Angle of reference right here. So 90 degrees, hypotenuse. Across from that angle, opposite, and here is your adjacent. Notice, I don't have an adjacent, but I have an opposite. An opposite is 12. So we got to go find our adjacent. My apologies. 12 goes down here. That's your opposite. Okay? Pythagorean theorem again. A square plus 12 square is equal to 15 square. Your hypotenuse will always be greater than the length of these two. These two must be smaller than 15, but must always add up greater than 15. So solve for a square. Minus 12 square, minus 12 square. So a square is equal to. So you will have 15 square minus 12 square comes out to be 81. Take a square root of 81. We are measuring distance. It will always be positive, so a is 9. So now we know this is 9. So 9 goes up here, okay? Simplify, 9 over 12. What goes into 9 over 12? Well, the greatest factor that goes into 9 and 12 is 3, so we're going to divide each by 3. 9 divided by 3 leaves you 3. 12 divided by 3 leaves you 4. So your final answer is 3 over 4. Fraction, ratios. Okay. Go on to number 10. It says, use the given point on the terminal side of an angle theta to find the value of your trig function indicated. All right, so you're going to use the given point on the terminal side of the angle. So make a little sketch of your coordinate plane. So I'm going to make a sketch. So you have an idea what quadrant it's in. This is quadrant 1, 2, 3, and 4. It always goes counterclockwise. All right, so first of all, you have -5, -10. So we're going to go -5 this way, -10 down, okay? That gives you your triangle. Your point of reference angle is always next to the origin. So now you have -5 and -10. You have to go and find your hypotenuse if it's needed. So check first. So sine theta, sine is opposite over your hypotenuse. -10 is your opposite. Right here is your hypotenuse. At this moment, you do not know what your hypotenuse is. Go and use your Pythagorean theorem to find it again. Okay? Here's your A, here's your B. Hypotenuse is always your C. This is always your right angle. So you're going to have 5 squared. Hypotenuse is always positive. If you do your Pythagorean theorem with a positive number, it will work out every single time. But if not, here's your -5 plus -10 squared is equal to your C squared, which is your hypotenuse. Okay? Just remember, when you square something, it is always positive. So you're going to have 5 squared, okay, plus 10 squared comes out to be 125. So this comes out to be 125 is equal to C squared. Take a square root of 125. A square root of 125 gives you a decimal, so you got to break it down. Factors of 125. 125 divided by 5 is 5 and 25. Factors of 25 is 5 and 5. 2 of a kind with that left over. So your hypotenuse is going to be 5 square roots of 5. Now you can plug into your ratios. Okay? So your opposite is -10. Your hypotenuse is 5 square roots of 5. You can either simplify it now and then rationalize it, or you can rationalize it first. I'm going to simplify first. 5 goes into both of those. That leaves that one -2. That leaves that one 1. Okay? So now you have -2 over square root of 5. You cannot have a radical in your denominator. Multiply the top and the bottom, the numerator and your denominator, by a square root of 5. This is basically a 1. You are not changing anything. So now you have -2 times square roots of 5 is -2 square roots of 5. Remember, we're looking for trig ratios. Must be a fraction. Square root of 5 times the square root of 5 is square root of 25, which is 5. And there you have your solution. Okay? All right. Number 12. Draw your coordinate plane. Make a quick little sketch to help you, just like that. Okay. You went -9, so you're going to go this way. Negative square root of 19, so you're going to go this way. Okay. So there you have your triangle with that point of reference. -9, negative square root of 19. Cosine. Cosine is your adjacent over your hypotenuse. Here's your adjacent. You do not have your hypotenuse. Go back to your Pythagorean theorem again. Hypotenuse is always your C. A squared plus B squared equals C squared. Okay? So you're going to take -9 squared plus square root of 19 squared is equal to your C squared. Or you can write H squared. So on your calculator, you go 9 squared plus, well, a square root of 19 is just, square root of 19 squared is just 19. And that gives you 100 is equal to C squared. Square root of that is 10. So your hypotenuse is 10. Okay? Now you can plug it in. Adjacent, -9, hypotenuse is 10. You can't simplify that anymore. There's your solution. Hypotenuse is always positive. Number 14. All right. make a sketch. Okay. 2, positive, negative 14 goes down. So here's 2 and negative 14. It's in the 4th quadrant. Angle of reference is right there. Secant is a reciprocal of 1 over cosine of theta. So if cosine is adjacent over hypotenuse, secant is going to be hypotenuse over your adjacent. Okay? As you can see right here, we do not have our hypotenuse also. So we're going to use our Pythagorean theorem. 2 squared plus negative 14 squared is equal to RC squared. So 2 squared plus 14 squared comes out to be 200. I'm going to go ahead and square root that. Okay? Factors of 200 is 102, and that's 10 and 10. So your hypotenuse is 10 square roots of 2. 2 of a kind, 1 left over. So let's plug it in. Hypotenuse, 10 square roots of 2 over your adjacent. This is your adjacent, always next to the reference angle. 2. 10 over 2. 2 goes into both. So 10 divided by 2 leaves you 5. 2 divided by 2 leaves you 1. So your final solution, what you have left, is just 5 square roots of 2. Okay? Or 5 square roots of 2 over 1. And there you have your ratios. Number 16. You are to find the value of the trig function indicated by what quadrant it is. It gives you the angle with the ratios, and it tells you what you need to find. So let's look at number 16. First of all, it tells you you are in quadrant 2. Okay? Quadrant 1, quadrant 2. That is where you are supposed to be. Then it says, so I'm going to go ahead and draw my triangle. Notice, one of the legs always touches your x-axis. Okay? Then you have right here, it says tangent theta of negative 5 over 12. Now, want to refresh your memory. This negative is the same thing as either negative 5 over 12. The negative can float up and down. It is also the same thing as 5 over negative 12. These two numbers are exactly alike. These are same answers. Your negative can float up or down because a negative divided by a positive gives you a negative. A positive divided by a negative gives you a negative. Make sure you are aware of that. So you have a tangent. Tangent is opposite over your adjacent. Okay? If you're going left on quadrant 2, this is negative. You going up, it is positive, and your hypotenuse will always be positive. If you know this information, the negative works itself out. So, tangent 5, that's your opposite. So 5 goes here. Adjacent is 12. So it's negative 12. So it's actually this one over here. Okay? Now that you know that, you can go see if this is one of your Pythagorean triples. You got a 5 and a 12. Is this one of your Pythagorean triple? And the answer is yes. 5 squared plus 12 squared will always equal 13 squared, which is just 13. If you are not sure, you can test out this math using your Pythagorean theorem. 5 squared plus 12 squared is equal to c squared. You will see it always comes out 13. This is one of those Pythagorean triples that works every single time. Now you have all those three numbers. You are going to go and find your sine. This is what we're looking for. See where it says find? That is what we're looking for. So, sine theta, this is always your angle of reference, touches the origin. So sine is opposite over your hypotenuse. What is opposite of this angle? 5 over your hypotenuse, 13. Cannot simplify anymore. And there you have your solution. Okay. Number 18. You are in quadrant 4. Make a sketch of your quadrant 4. 1, 2, 3, 4. Your triangle is down here. Notice how one of the legs touches your axis, the x-axis. There's your angle of reference. Okay? Sine. Going this way is positive, going down is negative. Hypotenuse is always positive. Sine is opposite over your hypotenuse. Where is opposite in accordance to this angle? 3. Where's your hypotenuse? 5. Okay. Take a look and see if this is one of your Pythagorean triple. If you do not know, you can go 3 squared, negative 3 squared, plus a squared or b squared is equal to 5 squared. You will see a always comes out to be 4 because this is a 3, 4, 5 triangle. It is one of the most common ratios in a triangle. Okay? Now that you have that, let's go find our cotangent theta. Cotangent theta. Cotangent is a reciprocal of 1 over tangent theta. So if tangent is opposite over adjacent, cotangent has to be adjacent over your opposite. See the reciprocal? Therefore, what is your adjacent? Adjacent is 4 over your opposite. What's your opposite? Negative 3. You can leave your answer like this, or you can float your negative up, so it'll be negative 4 over 3. These two are exactly the same answer. Okay? Number 20. Draw your second quadrant. Make a sketch. Doesn't have to be pretty. You just need to know it's in the second. 1, 2, 3, 4. 2's right here. Make a sketch of your triangle. Label your angle of reference. Going this way is negative, left. Going up is positive. Hypotenuse is always positive. Okay? So here's your secant. Secant is the reciprocal of 1 over cosine theta. SC, CS. See how they don't match up? All right. So if cosine is adjacent over hypotenuse, this has to be hypotenuse over your adjacent. Here's your angle of reference. Hypotenuse. 6. Adjacent. Touching that angle, negative 5. Do you see how your negatives and positive dealt with each other? So here we are trying to find your tangent theta. Okay? Let's see what we need before we do any math. So, tangent theta is adjacent over your, is opposite over your adjacent. Do we have an opposite? No. We do have an adjacent, which is negative 5. So we're going to have to use our Pythagorean theorem. I'm going to call this one A. Because my B looks like a 6, I'm going to call it an A. All right. Negative 5 squared. Notice I put parentheses around my negative. Plus A squared is equal to 6 squared. Okay? So A squared is equal to, I'm going to do it all in one step on my calculator. 6 squared. 6 squared minus 5 squared gives you 11. So A is equal to square root of 11. Okay? I know I can't make that. That's a prime number. So opposite is square root of 11. Fill that in. Can't simplify your ratios anymore. Radicals on top and not in the denominator. It's in the numerator. You are finished. Okay. Take a little deep breath. You will do just fine. It's the same thing over and over with a little bit more every single time. But you've got to know your so-called TOA, and you need to know the reciprocal of them. Please know your Pythagorean theorem. Hypotenuse is always your longest leg. It is always the C. And A and B are interchangeable. Okay? All right. Now we are going to convert from degrees to radians and radians to degree. So before I start, we are going to do just the even. Keep that in mind for the video. To go from degree to radian. Radian is just another unit of measuring angles. You're always going to have a pi in your answer. Whereas degree, you will always have this little symbol here, and I'm going to label it X to that degree, that little open circle, okay? So let's look at number 22. 22 says, I have a degree here. Well, if you have a degree, guess what you're going to do? You are going to convert it to radians. That's the other unit. So you're going to take -5. I want radians, so I'm going to put pi on top divided by 180. Okay? Just multiply across. This is like a 1 under here. So you're going to have -5 times pi divided by 180. So -5 pi over 180. Now, you could simplify this in your head, or you can use your calculator. So -5 divided by 180 gives you a decimal. You hit math frac, it will convert it for you. This is the same thing as -1 pi, which you don't have to write the 1, over 36. Okay, -pi over 36. Number 24. If you will look, you see how you have a pi in your solution? That means we are going to convert this to degree. We are going to get rid of pi. If pi is in your numerator, just like you see right here, you're going to multiply times 180 over pi. And the reason you want to do that, do you see how they cancel out? Okay? Then just multiply across. 24 times 180 divided by 7. 24 times 180 equal divided by 7. Okay? This gives you 617.1 degrees. If there's a decimal, just move it to, make sure you round it correctly to the nearest tenth, and I will be fine, knowing that is not a perfect degree. But what is a perfect degree? All right, pi, convert this to degree. So I'm going to take 3 pi over 5 times 180 over pi. Did you guys see how the pi cancels? Okay. Because they equal 1, so now you have 3 times 180 over 5. Calculator work. 3 times 180 equal divided by 5. It comes out to be 108 degrees. Perfect whole number. All right, 28. We have another pi. Okay? This time it's a negative. It does not matter. We are going to convert this to degree. The negative just tells you you are going to go clockwise instead of counterclockwise. That's the only thing it tells you. All right. Now if you look, you have -16 pi over 9. Remember that negative can float up or down. I'm going to keep mine on top. Times 180 over pi. Pi cancels. So you have -16 times 180 divided by 9. You really could have simplified this off the bat, okay? -16 times 180 divided by 9 gives you -320 degrees. I do want to do one more to convert from degrees to radian, just because our last 3 examples was going to degree, and there was only one to radian, so let me do one that goes to radian. And let's look at number 27, okay? I know I was going to do all the evens, but I want to make sure you guys really got your degree to radian. See how that's a degree? Convert that to radian. So you're going to take 50 degrees. Remember, radian, I want pi in my answer. Pi goes on top. This is the same thing as 50 over 1. So you're going to have 50 pi over 180. You need to simplify. 0 cancel itself. See how the 0 cancels? So all you have left is 5 pi over 18. Okay? So I just divide each one of those by 10. Basically is what I did. All right. Moving along. Now, for you to do this part with a special right triangle, there are some ratios that you need to know. If I were you, I would write this down somewhere so you can just refer to it every single time, and it will make it so much easier for you. Okay? So if you look, I'm going to make a sketch of a 30-60 degree triangle. Ignore that for now. So here's my 60 degrees. Here's my right angle. If that is 60, this will always be your 30. We are heading into the unit circle. So when we are talking special right triangles and we are looking for their trig functions, we are going to make their hypotenuse 1. Okay, 1 unit is what that means. So your hypotenuse will always be your radius when we head into the unit circle, and it will always be 1 unit. That's the measurement, is the unit. It could be 1 inch, 1 foot, 1 yard, but we're talking about a specific unit later on, but we're going to go with unit as a general term. So this will always be a 1. So in a 30-60, the ratio is your hypotenuse is always 1. If this is 30 degrees, keep in mind it's half of 60, 30 degrees, the opposite smallest angle corresponds to the shortest leg. So it is always half of 1. So this here will always be 1/2. Okay? What corresponds to the middle angle, 60 degrees, you always times the short with that. Square roots of 3 will always be 1/2 times the square root of 3, which comes out to be square roots of 3 over 2. So these are the ratios you always need: the 1, the 1/2, and the square root of 3 over 2. You need to have that memorized. It will make your life so much easier when you are heading into the unit circle. Okay? Next triangle. Is going to be your 45-45 that you need to know. Radius is a 1. 45-45. Same angle measurement, then the length are the same. Okay? So this here will be square roots of 2 over 2, square roots of 2 over 2. You must memorize this. This is the most common ratios for your triangles. Knowing these things, we're going to come back to it a lot. Remember, your hypotenuse is always the longest leg. It is always across from 90 degrees, longest leg. Okay? All right, now let's get started on number 30. It says cosecant of 330. Cosecant is the inverse of 1 over secant, not secant, I'm so sorry, 1 over sine of theta. Okay? And sine is opposite over your hypotenuse. So what you are going to look for here is hypotenuse over your opposite. So, first of all, you need to find out, it's already been converted to degrees, so you can skip that step. Second, you need to make a sketch. Okay? Right here is 0 degrees. You're going to rotate it 90. You're going to rotate again. This will be at 180 and this will be at 270 degrees. So where is the location of 330 degrees? It is between 270 and 0. So make a sketch of your triangle. Do you guys see how one of them always touches the x-axis? This will be your reference angle, okay? Your hypotenuse will always be a 1. Going right is positive, going down is negative. We are trying to find a ratios of hypotenuse over adjacent. All right, continuing on. It says we always start at this terminal side right here, your positive x-axis. We have rotated 330 degrees. Now remember, this is 0. When you go around the whole circle, it is 360. So if you have gone around 330, what must this angle be? Well, what is 360 minus 330? So you've gone 330 to get to 360. You're going to subtract. That will give you 30 degrees. Okay? You see that right there? Now start labeling what you know. Go back to this chart. 30 degrees. What is the length of the measurement that corresponds to 30 degrees? 1/2. What corresponds to 60? Square roots of 3 over 2. Do you guys see where I'm getting these numbers from? From my ratios over here. Okay? Now that you have the length of all three sides, you can now find the ratios. First step, convert to degree. Already happened. Second step, make a sketch of your triangle with the correct degree. Same right quadrant. Done. Third step, write your ratios. All right. So now you have cosecant of 330 degrees, okay, is hypotenuse over adjacent. Hypotenuse is 1. Hypotenuse over opposite. Hypotenuse is 1. The opposite is negative 1/2, okay? I never want to see a fraction in your denominator. You must take care of it. Now, some of you might have a hard time seeing this, so I'm going to rewrite it so where you could kind of follow a little easier. This is the same thing as 1 divided by negative 1/2. Did you guys see that? If you can do it from here down to here, then don't redo this step. But this is just to kind of let you see a little bit what's going on. All right, bring down your 1. The first number always comes down. What is the inverse of division? Multiplication. When you decide to change this from division to multiplication, you have to take the reciprocal of that number. So this comes out to be negative 2 over 1. Okay? What is 1 times negative 2? Negative 2. This is like 1 over 1. What's 1 times 1? 1. So your solution comes out to be negative 2. So that was kind of like the long way around it, just to make sure you have it. So the next two problems I'm going to do, I'm going to go a little bit faster. But just remember, I'm going to keep referring to this every single time. You need to write this somewhere to have quick access. So that way this will make it a lot easier. Okay? The more you use it, the easier you're going to know it, the easier it's going to come to you. All right. Number 32, tangent, pi over 4. Okay? Step number 1, it is in radian. So we're going to take pi over 4. We're going to convert this to a degree first. All right. So this comes out to be tangent. Pi times 180, pi cancels, so just 180 divided by 4, which is the same thing as 45 degrees. Okay? So tangent pi over 4 is the same thing as tangent 45 degrees. Make a sketch. Positive, counterclockwise. 0 degrees, 90 degrees, 180 to 70. Where is 45 degrees? Between 0 and 90. And there's my triangle. Notice it's touching the x-axis on the leg. There's your reference angle. You have traveled starting right here. How many degrees? You went this way. How many degrees did you go up? 45 degrees. Hypotenuse is 1. Going to the right is positive. Going up is positive. Look at your reference angle again. 45 across from it is square root of 2 over 2. Over here, square root of 2 over 2. Okay, so there's your ratio. So, tangent of 45 degrees. Please write the word tangent 45 degrees. Tangent is opposite over your adjacent. Here's your reference angle. What is opposite from it? Square root of 2 over 2 divided by square root of 2 over 2. See how these two are exactly alike? It's kind of like 3 over 3. So anything over itself is always 1. Okay? If not, you would have to take the reciprocal if you have a fraction or radical in the denominator. Number 34. Moving along. It's already in degree. You're good. Okay? Draw your triangle. Oh, I was using red. This is 0, 90, 180 degrees. And right here is 270. Positive. Now, if it was negative, you would go you would go clockwise. Okay? You would go this way. But it's positive, so you're going to go counterclockwise. Where is 135? Right over here. Second quadrant, between 90 and 180. Angle of reference, 90 degrees. Okay? So here you have gone 135 degrees. Well, if you've gone 35, so what's this little piece angle going to be? You're going to take 180 minus 135. And that gives you to be 45 degrees. And that's how you get 45, because 135 plus 45 gives you 180. Linear pairs. All right. Knowing that, hypotenuse is 1. Going left from the origin is negative. Going up is positive. Go and use your 45 degree triangle ratios, and now you can take it from there. Cosine of 135 degrees. Cosine is adjacent over your hypotenuse. Adjacent, that's the x-axis, is negative square root of 2 over 2. Over your hypotenuse, which is 1, anything over 1 is itself. Negative square root of 2 over 2. Okay? Number 36, continuing on. All right. Notice it's in radian. You have to convert it to your degree. So I'm going to multiply 180 over pi. Pi cancels. That comes out to be cosecant, okay, on your calculator. 5 times 180, enter, divided by 4. That gives you 225 degrees. That means these are the same position, okay? These are exactly the same position. Look at 34 real quick. That means 135, 32. Let's look at 32. This angle here is 45. You've gone 45. Same thing as pi over 4, which you guys will learn later. All right. Draw your coordinate plane. Okay. This is 180. This is 270. So where is 225? Well, between these two. Angle of reference. See it right there? All right. So you have gone 225 from there to there. This is your initial starting point every single time. So where is that angle going to be? Well, if this is 180, okay, you're going to take 225 minus 180. So from here to here is 180. From here to here is 180, and I want to go a little bit more. That will tell me what that angle is. So what is 225 minus 180? This comes out to be 45 degree again. Now guys, it's not always going to be 45. It just happens to be 45 here. Okay? Sometimes it'll be a 30-60. The next problem will be a 30-60. All right, so you got 45. Hypotenuse is 1. Going this way is negative. Going down is negative. Square root of 2 over 2. Square root of 2 over 2. So you have all your length to find your ratios. Cosecant of 225. Remember, cosecant is the same thing as 1 over sine theta. Okay. So cosine is opposite over hypotenuse. So this one's hypotenuse over opposite. Hypotenuse is 1. Your opposite, point of reference, so across from it is negative square root of 2 over 2. See how that's a fraction underneath, in the denominator? We got to rationalize it. So this comes out to be 1. Instead of dividing, you're going to multiply, and you are going to take the reciprocal. Negative 2 goes on top, square root of 2. Remember, the negative can float up and down. All right, what is 1 times negative 2? Negative 2 over square roots of 2. You see how you have a radical in your denominator? You have to rationalize it. So multiply it times itself. Negative 2 times square roots of 2 is negative square roots of 2. 2 times 2 is 2. Okay, simplify please. What goes into both of them? 2. So negative 2 divided by 2 leaves you negative 1. 2 divided by 2 leaves you 1. So your final solution, okay, the cosecant of 225 is going to come out to be negative square roots of 2. There you go. So hypotenuse over your opposite. Last one, number 38, okay? It's in radian. Converted to degree. 180 over pi. Pi cancels out, okay? convert that to degree. So 5 times 180 equal, divided by 6, gives you 150. So cosine of 150 degrees. Draw your triangle. Draw your coordinate plane first. So here is 0, 90 degrees, 0 over 360, same position. 180, 270. Where is 150? Well, it's between 90 and 180. So here I have my triangle. 1. Radius is always 1. There's your angle of reference. Going this way is negative, going up is positive. Okay? Now take it from there. You went 150 degrees. So from here to here was 150. Well, what is this little angle going to be then? Well, what's 180 minus 150? Gives you 30 degrees. Go back to your reference angle that you keep looking at. What is always across from 30? 1/2. Notice my triangle is not proportional. Don't worry about it, okay? So if this is 30, this has to be 60, and across from 60 is square root of 3 over 2 every single time. Now, let's do our ratios, find our ratios. Cosine of 150 degrees. Cosine is adjacent over your hypotenuse. Here's your angle of reference. What is your adjacent? Negative square root of 3 over 2 over your hypotenuse, which is 1. What is anything over 1? Negative square root of 3 over 2. Okay? I hope you guys will do well on your big quiz for my class. If I have made any mistakes as I kind of rush through this a little bit, do let me know, and I will be adding it on. So, other than that, good luck.